the that j of minus half x it is root under 2 by pi x cos x. That's all. So let us see the proof. Now what is the formula for Jnx? Can you tell me Jnx summation form minus 1 to the power m x to the power 2m plus n divided by this m factorial and what? And are there any other term? Gamma m plus nu plus 1. Here nu means n. Okay, better to write nu. New. That is a formula, right?
Yes, sir.
Now here nu is equal to half. We have to find the expression for j half. So I am taking nu is equal to half. Therefore j half x. It will be what? Say m 0 to infinity minus 1 to the power m x to the power 2m plus half divided by 2 to the power 2m plus
Half.
half, then m factorial gamma of m plus 3 by 2.
3 by 2.
This one. Now look, there have a term square root of 2 by pi x. All of we know that there have a series for sin x. There have an infinite series for sin x. Okay, and it is the common term square root of 2 by pi x. So better firstly you take that root under 2 by pi x common. So what I can do, I am taking square root of 2 by pi in the outside of this summation. Okay, sorry, not 2 by pi, 2 by
2 by
x.
x.
So it will be what? Look, I have taken extra x to the power half na, in the denominator. So I have to multiply x to the power half in the numerator.
Yes, sir. So
Therefore, it will be what? X to the power 2m plus 1
2m plus 1. Yes, sir.
and root square root of 2. I have taken extra. It is in
Yes,
the
sir. So 2 to the power
numerator.
2m plus 1.
Multiply that root 2 in the denominator. It will be 2 to the power 2m
Plus
plus
1.
1. Have you understood, everyone?
Yes, sir.
Others?
Yes, sir.
Okay. Now, uh, do you know what is the series for sin x? Summation form? What is the series for sine x? That you should know. X minus x cube by factorial 3 plus x to the power 5 by factorial 5 minus x to the power 7 by factorial 7 and so on. That is the series for sine x. I told, I think, in the class that you should remember some well-known series like sine cos e to the power 1 plus x to the power minus 1, 1 minus x to the power minus 1. And this type of series you should remember. These are well-known series. So in summation form, I can write what? X to the power 2m plus 1 divided by 2m plus 1 factorial minus 1 to the power m, m0 to infinity. You see, can I write this?
Yes, sir.
Minus 1 to the power m, x to the power 2m plus 1 divided by 2m plus 1 factorial. It is the summation form. Now, here you see in the numerator we are getting that similar one, minus 1 to the power m x to the power 2m plus 1, and in the denominator we have something else. So what is our target? Our target is to convert that denominator into that 2m plus 1 factorial. Then we are done. Right.
Yes, sir.
And another actually another that 1 by root pi term will be there. So ultimately, actually, the denominator you have to simplify. I am clearing the frame. Now I am taking the denominator 2 to the power 2m plus 1 2m plus 1 into m factorial into gamma of m plus 3 by 2. Now I am writing this as 2 to the power m into m factorial 2 to the power m plus 1 into gamma m plus 3 by 2. Can I write this?
Yes, sir.
Look, I have splitted this 2 to the power 2m plus 1 into 2 to the power m and 2 to the power m plus 1. Then I am multiplying 2 to the power m with m factorial and 2 to the power m plus 1 with gamma of m plus 3 by 2. Now, this part. So there are actually m number of 2's, and if you expand this m factorial, it is what? I can write 1, 2, 3, 4 up to m. Are you getting?
Yes, sir.
That factorial m. Factorial m means what? 1, 2, 3, 4 up to m, product of this.
Yes, sir.
And this 2 to the power m plus 1 into gamma m plus 3 by 2. Now see, for it is actually what? Gamma m plus 3 by 2 means 2m plus 3 by 2. So it is of the form something by 2. Whenever gamma of something by 2 is given, actually its tail looks like what? Where it will be stopped? You think? Like I'm giving you two example. Gamma say 5 by 2. So gamma 5 by 2 I can write 3 by 2, gamma 3 by 2. Then gamma 3 by 2 I can write half gamma half, right? So 3 by 2 into 1 by 2 into gamma 1 by 2. So by the property of gamma I can write gamma 5 by 2 is equal to 3 by 2 into 1 by 2 into gamma half. Is not it? What is the property I have used? Gamma alpha plus 1 is equal to alpha gamma alpha. Similarly, gamma say 11 by 2. So gamma 11 by 2, that is 1 plus 9, 1 plus 9 by 2. So 9 by 2 gamma 9 by 2. Then again gamma 9 by 2, it can be written 7 by 2
9 by 2, 7
minus
by
7
2.
by 2. Then gamma 7 by 2, it can be written what? 7 means 5 by 2 gamma 5 by 2, and in that way I can write 5 by 2, then next term will be 3 by 2, then next term will be 1 by 2, and last will be is it stopped here, right? So what I told, that always for every means whenever we are finding gamma of something by 2, its tail will be in that form, means it is gradually decreases in the form 5 by 2, 3 by 2, 1 by 2, and at last it is gamma half, right? You can
Yes, sir.
start with another value also, gamma of say uh, 15 by 2, you can do it. So tail will be like that. So what I can write for that, it is 2m plus 3, fine. So 2m plus 3, we can write 2m plus 3 by 2. So it is basically 2m plus something plus 1 I want to write. 2m plus 1 by 2 plus 1. Can I write this? 2m plus 3 by 2, that is 2m plus 1 by 2 plus 1. Then in the first step, it will be what? 2m plus 1 by 2 gamma 2m plus 1 by 2. And then you decrease the term by 1 and continue. So 2m plus 1 by 2, next term will be 2m minus 1 by 2, then 2m minus 3 by 2. In that way, it will be after some certain step 5 by 2 you will get, then 3 by 2, then 1 by 2, then gamma half, right?
Yes, sir.
Now see the 2 to the power m into 1 into 2 into 3 into 4 into m. So I can distribute that m number of 2's into each value, means 2 into 1, 2 into 2, 2 into 3, 2 into 4 up to 2 into m. I am distributing that m number of 2 in each place. Means I am distributing that each 2 in, you can think that as a box. So there are m number of box, and in that m number of box I am distributing 2. So ultimately it will be what? 2 into 4 into 6 into 2m for this part. Is not it?
Sir, yes, sir.
Simply multiplication. Actually, see, 1 into 2 into 3 into 4 into m I have, and I am multiplying it by 2 to the power m, right? So 2 into 2 into 2 into up to m number of 2, isn't it?
Yes, sir.
So I'm multiplying this, this, then this. M number of 2's
Oh,
are there
yes, sir.
and
Yes,
m
sir,
number
got
of
it.
terms. So I'm multiplying each term by 2.
Yes, sir,
It is
got it.
ultimately multiplying by 2 to the power m. Get it?
Yes, sir.
Understood now?
Yes, sir.
Okay, and this second term also, there are 2 to the power m plus 1 term, na? So m plus 1 number of 2's, and here how many terms are there? How many terms are there? You just count the numerator values 1, 3, 5, 7, then up to 2m minus 1, then 2m plus 1.
Sorry, m plus 1.
M plus 1. Actually, 1 to 2m minus 1, odd numbers you count 1, 3, 5, 7 up to 2m minus 1. That is m. And another one 2m plus 1 is there. So m plus 1 number of terms are there. Okay. Now I can distribute that m plus 1 number of 2's in each boxes like previous. M plus 1 number of terms, na? After multiplying 2, it will be what? 2m plus 1, 2m minus 1, 2m minus 3, then 5, 3, 1, gamma up. Right? Now you rearrange, just a minute. Yes, sir. Sir, I'm in the class actually. I'm taking class. Yes, sir. By 6. Mm-hmm. Cheers. Okay. So here, now if you arrange these values in descending order or ascending order, then the values will be like that. Now, the maximum value it is 2m. Next value, sorry, maximum value 2m plus 1. Then 2m. Then 2m minus 1. Then next term will be 2m minus 2. And it comes from here. In that way, in between 5 and 3, 4 will be there. Then in between 3 and 1, 2 will be there. Right? So
Yes, sir.
you can arrange these overall things in ascending order or descending order. So ultimately what we will get?
So 2m plus 1 factorial.
2m plus 1 factorial, right? Means it is coming 1 into 2 into 3 into 4 into 5 into 6 up to maximum 2m plus 1 after rearranging. So it is 2m plus
Plus 1
1
factorial.
factorial. Okay. And rest of the term, only one term left, gamma half. So which is root pi. Therefore, that j half, it is what? The denominator part you substitute that 2m plus 1 factorial into root pi, right? example, I can write simply that root pi, you can take this outside the summation, and it will be 2 by pi x, and the rest of the series it is sin x. Okay.
Yes.
So the main part is here, how to write 2 to the power 2m plus 1 into m factorial into gamma m plus 3 by 2, it is equal to 2m plus 1 factorial into root pi. You have to show it in details. Okay, don't write directly, because means it is asking for proof there, therefore you know what should be the denominator. You are writing just directly this equals to 2m plus 1 factorial into root pi. Don't do it. You show the calculation how we are getting 2m plus 1 factorial into root pi. Okay, now how to get j minus of x is equal to root under 2 by pi x cos x. Look, actually you can do the similar process for minus up. Okay, and also you can do one more thing. Actually, every time you just remember the technique for j half x, and then you do one more, do one small trick. What is the trick? You apply some property on that first one. Okay, you apply some property on that first one, so that you will get this. So if they ask, so this means instead of the first proof they are asking for second proof, what you will do? You can do one thing, you prove j half is equal to this, and then apply those Bessel's property to get the required one. Now how to apply it? Tell me which property. Look, first property, what is the first property? Can you tell me? Dx of x to the power nu j
J
nu
new
x
x
is equal to
x to
x
the
to the
power
power
new
j
J new minus 1 x.
1 x. Now, if you take look, if you take nu is equal to half, so it will be relation between j half and j minus half, na? Are you getting or not? I
For
am
what?
taking nu half, so it will be then d dx of x to the power half j half x is equal to x to the power half j minus half x. Now d dx of x to the power half means root x, and what is j half? You put it by the previous result. J half means square root of 2 by pi x sine x is equal to it is root j minus half x. Now that square root of x cancel out, and root under 2 by pi it is constant, then it is only d dx of sin x, so it will be what? Cos x. Therefore j minus half will be that root x, it will be coming to the denominator. Fine. So it is the easiest way to prove that root under 2 by pi x j minus half is equal to root under 2 by pi x cos x. Okay, but If it is asked to prove only this, don't show only this part. Before that, you have to prove j half x is equal to square root of 2 by pi x sin x. Do you get it?
Sir.
Don't apply the property directly and don't write j half is equal to, we know that square root of 2 by pi x sin x. You have to prove it first. J half is equal to square root of 2 by pi
Sir,
x.
in exam we can prove j half and do this process to find j minus half.
Yes, that I told. Actually, otherwise there are some other derivation. J means in that j nu x formula you put nu is equal to minus of, then simplify and then try to get the summation form of cos x. Okay, that you can do. But better you store something less in your brain. Okay, no need to store for j minus up. Are you getting what I told?
Yes, sir.
Yes.
Fine. Now by using this j half and j minus half, someone can ask what will be j of 3 by 2. Okay, j of 3 by 2x or j of minus 3 by 2x. By using j half and j minus half, you can find j 3 by 2, j minus 3 by 2. How? By using those properties. Okay, so you tried how to get this. You can use j half, j minus half directly here. Okay, but you have to apply some property. Which property? That is your choice. Okay, now the last part, actually last type of problem, which is related to integration. Now, how these formulas are coming? Integration x to the power nu j nu minus 1 x dx is equal to x to the power nu j nu x plus c, or integration x to the power minus nu j nu x dx is equal to minus x to the power minus nu j nu x plus c. How we are getting this basic integration formula? From the properties. So how? Look, simple. Matlab, the properties are given in derivative form na, ddx of something. From the first property you take integration both side. Okay, so integration ddx of this, it will be what? Neutralized na, integration and ddx neutralized. Integration, that will eliminate the derivative. So left side it will be simply x to the power nu j nu x, and right side integration x to the power nu j nu minus x. That's all. So that is the formula actually, and due to that integration we are taking arbitrary constant. Do you get it or not? I am taking integration both side. So after taking integration, left side will be what? X to the power nu j nu x, and right side will be in that form, x to the power nu j nu minus 1 x. Okay, dx. And since we are integrating, we are taking an arbitrary constant. Do you get it? How I am getting the basic formula of integration? Means if you integrate x to the power nu j nu minus,
Mm-hmm.
you can add this c in the left side. That will be better actually. Plus c. On x is 1 x dx is equal to minus x to the power minus nu j nu x plus c. Can I write this?
Sir, can you explain again?
Look, I am taking integration both side to get the formula. So left side will be what? Integration of d dx of this. Integration d dx of fx. That means what? Fx only.
Yes, sir.
So that is this one. X to the power minus nu j nu x. And here, because of that minus sign, I am moving that minus sign to the other side. Okay, so this minus sign I am writing, and it is remaining in the integration form.
Yes, sir.
So here the formula is integration x to the power minus nu j nu plus 1 x dx is equal to minus x to the power minus nu j nu x plus c. From the third, we will not get any integral formula. From the fourth, I will get some integral formula. What will be the integral formula? You take both side integration, then it will be what? J nu x plus c is equal to integration of j nu minus 1 minus j nu plus 1. Right? Are you getting or not? Do I need to explain more? Do I need to explain more in details? The main thing I am using integration of f dash x. ये क्या होता है? That is fx plus c. Isn't it?
Yeah. Yes, sir.
That thing I am using here. It is also derivative. So if you take integration, that derivative will be eliminated. And for the second also. Now you can see the formulas again. This one. So that is one formula, x to the power nu j nu minus 1. It is equals to x to the power nu j nu, and x to the power minus nu j nu plus 1. It is minus x to the power minus nu j nu x plus. And it is from the third. Means, sorry, that fourth property. Now we have to prove it, what they go. So that integration of x square j naught x dx is equal to x square j1 x plus x j naught x minus integration j naught x dx. I have to prove this. Now how to prove it? You have these three formula. Most applicable formulas are this. Formula number 1 and 2. That is not that much useful. You can ignore it. Now see, I am showing it how I have done. X square j naught x. Okay, integration x square j naught x. That I have to show this. So I am doing actually by parts. But in that by parts, you have to fix which one you have to take as first function and which one you have to take second function. So I am writing x square j naught x in the form x into x j naught x. Why? Why I am writing it in the form of x into x j naught x? Because that means after putting the particular value of nu, we will get this. You see the formula. In this formula, you think if I put nu is equal to, say, directly, can I get nu means x square j naught x integration? it is x to the power nu j nu minus 1. So if I take nu 2, x square j 1 I will get, or x to the power minus 2 j3 हो जाएगा, that will be also not acceptable. So from the first you think, if you take nu is equal to 2, it will be x square j1, but it is not, in the problem it is not x square j1, it is x square j naught. If you take nu 1, it will be x j naught. So if you take nu is equal to 1 in that formula, I am getting x j naught, not exactly x square j naught. Okay, so that is why I'm splitting it into x j naught. Okay, do you get it? What is the need of this splitting x square j naught as x into x j naught? To apply this formula directly, I cannot apply this formula. So now in the by parts formula, you take that x as the first function and the remaining as the second, because means there are integration form in the Euler formula, there are integration form of the second function, right? So x into, by taking by parts, x into integration of x j naught x minus integration d dx of x, that is 1, and another integration of x into j naught x dx. Now you see how I can substitute the value of this integration. So you try to reduce the number of integrations. Okay, you try to reduce the number of integration. Now I can reduce that integration into a Bessel function. So x into j naught integration by the first formula. In the first formula, if I put nu is equal to 1, then what will be the value? X integration x into j naught is equal to x into j1, right? Integration of
Yes,
x,
yes.
x into j1. So I am putting x into j1. Similarly, for that integration, I am putting x into j1. Now that part is simplified. There have no integration, but in the second term there have an integration. So I have to try to eliminate it. Always you cannot eliminate, but your try should be eliminate the integration. Now x into j1, x into j1, have there any means formula for it? For any particular value of nu, can you get x into j1 integration? You think x into something means if you take nu 1, then x into j naught, x square into j1, they are right. If you take nu is equal to 2, it will be x square into j1, but there don't have x into j1, right? That don't have the term x into j1. We will not get that value of this integration directly by putting any particular value of nu. So what I am doing, I am applying some by parts here. Again, I am applying some by parts, taking j1 first function, sorry, x first function, j1 second function, then x into integration j1x plus integration of d dx of x, that is 1, and integration again j1x dx. Now integration j1x, integration j1x, have there any formula for it? Integration j1x, you think? Integration j1x, you think about these two formula and any particular value of nu.
Second one.
In the second formula, if you put nu is equal to 0, if you put nu is equal to 0, then it will be integration j1x, and it is what? Integration j1x is equal to x to the power 0 1 j0 minus j naught x, right? If you put nu is equal to 0, this side minus j naught x, So integration j1x, it is actually what? J naught minus J naught. Are you getting or not? Now I am putting integration j1 minus J naught to minus minus plus J naught x into J naught, and here there are two integrations. So integration j1 you substitute, it will be J naught, and lastly we are integration means we are getting integration of J naught. Actually that is the last form, that is the that we have to prove. Integration J naught, it will be there, you cannot simplify it further. So you see the rest of the terms we are getting x square j1 x into J naught and integration J naught. Okay. So similarly, you think it is problem number 24, x to the power minus 1 into j4. Okay, x to the power minus 1 into j4, you cannot integrate it directly, means because there are no formula in that form for any particular nu. So what we are doing, we are adjusting this integrand in that way, x square into x to the power minus 3 j4 x dx. X square into x to the power minus 3 means x to the power minus 1. Now we are thinking that as a single function, x to the power minus 3 into j4x. Now there is a formula actually for x to the power minus 3 into j4x dx. See, in the second formula, if you put nu is equal to 3, so it will be x to the power minus 3 j4x, right? So x to the power minus 3 j4x integration will be minus x to the power minus 3 j3x. So in after that we have done by parts, and then we are getting this integration minus x to the power minus 3, sorry, integration of x to the power minus 3 j4x, and it is what, as I told, minus x to the power minus 3 j3. We are substituting, and similarly for that I am substituting. Next simplifying, so there are no integration term here, and for the second, this, it is 2 into integration of x to the power, after simplifying what we are getting, 2 into x to the power minus 2 j3x dx. Okay, now again we can apply the formula for particular new. देखो यहाँ पे अगर new को 2 ले लेते हैं in that second formula, it will be x to the power minus 2 into j3 integration. So integration देखो x to the power minus 2 into j3, it will be what, minus x to the power minus 2 j2. तो माइनस एक्स टू द पावर माइनस 2 into j2, and 2 तो था, and after integration I am writing arbitrary constant. Okay, since in an indefinite integral there I have an arbitrary constant. So देखो here I am getting a simplest form which do not contain any integration terms, means it is completely simplified, there are no integration terms. In the previous proof we cannot simplify further after integration j naught x, but here we can, we are getting this. Okay, everywhere we are using actually that those four properties, and most important properties means which are used in 80 or 90% places, property number 1 and property number 2. In most of the cases we are using which properties? What happened? Everywhere we are using these two properties. Fine.
Yes.
So I did 23, 24. You can try 25. There means in some previous semester I have seen some of the problems are wrong. Means among these three, it is correct. It is correct. Maybe 25. It can't be solvable. You can try. Actually, it is different from the PDF and hard copy. In hard copy, it is different. So maybe there is some problem with problem number 25 in the PDF or in the hard copy. I don't remember exactly. You can try integration J5 if you can handle it. Okay, that's all about that Bessel's function and chapter 5. So that is the end of chapter 5. That Bessel functions of second kind. It is not in your syllabus. J knew that was what? Bessel function of first kind of order n. Order new. Here Y knew it is the Bessel function of second kind of order nu. Okay. So it is not in your syllabus. Next, in the next class, we will start chapter 6. Phrase chapter, and I think you will enjoy it.
सर मिड सेम में चैप्टर 6 तक आएगा.
हाँ, चैप्टर 6 में भी एक
सर मिड सेम में चैप्टर 6 रहेगा.
यस, चैप्टर 6 में एटलीस्ट 6.1 एंड 6.2 ये दोनों रहेगा.
ओके सर.
ओके सर. सर
ओके सर.
हाँ बोलो, आप कोई कुछ बोल रहे हो? और कोई कुछ बोल रहे हो क्या?
Sir, attendance.
सर अटेंडेंस.
Attendance I will give all present.
ओके सर.
Sir, chapter 6 complete.
हाँ, chapter 5 complete.
No, sir, chapter 6 पूरा आएगा मिड सेम में.
No,